Assalamualaikum, nama saya Muhammad Irwan Syafrin bin Rostam. Nombor pendaftaran saya 13DKA21F1101. Hari ini kepala kami akan membentangkan topik 3 iaitu hidrodinamik. Introduction. Flow of conserved quantity. Branch of physics that deal with the motion of fluid and the force acting on solid bodies immersed in fluid and in motion relative to them. The system has to be describable as a complete identity like a liquid or gas, rather than a collection of individual particles.
Assalamualaikum. My name is Nur Hayati binti Mama. My matric number is 13DKA21F1041. Laminar flow, tubular flow, and transition flow. When fluid particles move along, we define path of streamline and the path of parallel and straight. This is laminar. Thus, particles move in laminar of layer clearing smoothly off the adjacent layer. Laminar flow generally happen when dealing with a small pipe and low flow velocity. If particles with higher velocity move in a zigzag manner and edit are formed, the flow is called turbulent. Turbulent flow happen is generally at high flow rate and with larger pipes. Turbulent flow are unsteady flow. Transitional flow occurs in a critical zone when the average velocity changes the flow from laminar to turbulent. Today, I want to present about laminar flow, turbulent flow, and transition flow. First, laminar flow. Number 1, Reynolds number less than 2000. Number 2, low velocity. Number 3, dye does not mix with water. Number 4, fluid particle moves in straight line. Second, transition flow. Number 1, 2000 less than Reynolds number less than 4000. Number 2, median velocity. Number 3, Felimet oscillus and mid slightly. Thirdly, turbulent flow. First, number 1, Reynolds number less than 4000. Number 2, high velocity. Number 3, dye mix rapidly and completely. And number 4, particle path completely irregular. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Nurudina binti Matuddin F1085. Uniform and non-uniform flow. When contain fluid characteristics like velocity, density and pressure do not change with respect to space at a given time, the flow is uniform flow. If the above flow characteristic or parameters change with space at a given time, the flow is non-uniform flow.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amira Akila binti Muhammad Shukri. My registration number is 13DKA21F1080. I would like to explain about steady flow and unsteady flow. Steady flow is defined as that type of flow in which fluid characteristics like velocity, pressure, density at a point in space do not change with time. Unsteady flow is that in which the above flow characteristic at a point in a space change with respect to time.
Assalamualaikum and good morning to my lecturer and my fellow friends. My name is Firdaus bin Sasuddin and my registration number is 13DKA21F1090. So I'm here to discuss about a question from Chapter 3, Hydrodynamics. So here I will give some example of a question. A Newtonian fluid with a dynamics or absolute viscosity of 0.28 Newton second per meter squared and a density of 800 kg per meter cube flows through a 55 mm diameter pipe with a discharge of 25 liter per second. So for the first step, I will do is to list down all the information given in a blank paper. So we write down dynamic viscosity equal to 0.28 Newton second per meter squared, and density equal to 800 kg per meter cube. Diameter 55 mm, we need to change it to SI unit, so it will be 0.055 meter, and discharge or flow of rate Q equal to 25 liter per second, we need to change it to 0.025 meter cube per second. So we go back to the question. So here the question need us to find the velocity of the fluid, Reynolds number of the fluid flow, and type of flow. So first we need to find the velocity. To find the velocity, we need to find the area first. So area equal to pi d power of 2 divided by 4. This formula we need to remember this formula because it is not given in the exam. So diameter, we know it already from the question above. So we need to put it into the formula. So area equal to pi multiply by 0.055 power of 2 divided by 4, and then we will get 2.376 exponent negative 3 meter squared. And then we use for the discharge formula. So Q equal to area multiplied by velocity, and then we change the formula to V equal to Q over A, and then we will get 10.522 meter per second. And then we find the Reynolds number. So Reynolds number equal to density multiplied by velocity and multiplied by diameter over dynamic viscosity, and then we put all the information in the formula, and then we will get 1653.457. As my friends speak just now, we will know that 1653.457 it in category of laminar flow. Laminar flow. So for the laminar flow, it need to less than 2000. That's all from me. Thank you.